Have you ever looked up at an airplane and wondered, how does something so heavy fly? It's a question that has fascinated people for generations. After all, airplanes are made of tons of metal, packed with passengers, luggage, and fuel. Yet, they glide gracefully through the sky, sometimes for hours at a time, crossing oceans and continents. It seems almost magical, like a giant metal bird defying gravity. The roar of the engines, the rush down the runway, and then, suddenly, the wheels leave the ground. For a moment, it really does feel like a magic trick, as if the laws of nature have been bent just for this machine. But it's not magic at all, it's science. Every flight is a triumph of human ingenuity and our understanding of the natural world. Airplanes fly because of some clever engineering and a bit of help from the laws of physics. Engineers and scientists have spent decades perfecting the design, making sure every part of the plane works together to conquer gravity. Let's take a closer look at the amazing science that lets us soar through the air. Understanding how flight works can make your next trip even more fascinating, and it all starts with something you've probably experienced yourself. Think about holding your hand out of a moving car window. You feel the air pushing against it, right? If you tilt your hand, you can make it rise or fall just by changing the angle. That's a small taste of the forces at play when an airplane flies. That's the same force that helps airplanes fly. This force is called lift, and it's created by the special shape of an airplane's wings. Without lift, flight would be impossible. The wings of an airplane are curved on top and flatter underneath. This special shape isn't just for looks, it's designed to manipulate the way air flows around it. The curve, called an airfoil, is the secret to generating lift. As the plane moves forward, the air splits and flows over and under the wings. Because of the curved shape on top, the air traveling over the wing has to travel a longer distance in the same amount of time, making it move faster. The air underneath moves more slowly. This difference in airspeed is what creates lift. The faster moving air above the wing creates lower pressure, while the slower air below creates higher pressure. This pressure difference pushes the wing, and the whole airplane, upward. But how does faster air help the plane fly? That's where a very important principle called Bernoulli's principle comes in. This scientific idea explains how changes in airspeed lead to changes in pressure, and it's the key to understanding how those massive airplanes stay in the sky, flight after flight. Bernoulli's principle states that faster-moving air has lower air pressure. Remember the curved top of the wing? Since the air is moving faster over the top, the air pressure there is lower compared to the air pressure underneath the wing. This difference in air pressure creates an upward force on the wing. That's lift. The faster the air flows over the wing, the stronger the lift force becomes. That's why airplanes need to speed up on the runway before they can take off. It's like blowing over a piece of paper held just below your mouth. The paper rises because the faster-moving air above it creates lower pressure, pushing the paper up. This same principle is at work when you hold the top of a piece of paper near a running tap. The water, moving faster than the surrounding air, creates an area of lower pressure, causing the paper to be pulled towards the stream. You might be surprised to learn that airplanes get some of their design inspiration from nature, specifically from birds. Just like airplanes, birds have wings that are curved on top and flatter underneath. This shape helps them generate lift, allowing them to soar through the air. However, there are some key differences between bird wings and airplane wings. Birds can flap their wings, which helps them generate more lift and maneuver with incredible agility. Airplanes, on the other hand, rely on their engines to move forward and their fixed wings to generate lift. While airplanes may not be as agile as birds, they more than make up for it in speed and distance. Thanks to powerful engines and aerodynamic designs, airplanes can carry us across entire continents and oceans, connecting people and places in ways that would have seemed impossible just a century ago. Now, lift isn't the only force acting on an airplane. When you see a plane soaring high above, it might look effortless, but in reality, there's a constant battle of forces happening every second it's in the sky. In fact, there are 4 main forces at play: lift, weight, sometimes called gravity, thrust, and drag. Each of these forces has a unique role, and together, they determine whether a plane climbs, cruises, or descends. Think of it like a tug-of-war in the air. Each force is pulling or pushing in its own direction, and the outcome depends on which forces are stronger at any given moment. We already know that lift is the upward force that pushes the plane up. It's created by the wings as air flows over and under them, allowing the plane to rise off the ground. Weight, on the other hand, is the force of gravity pulling the plane down towards the earth. This is the same force that keeps us grounded, and it's always working against lift. Thrust is the force that moves the plane forward. It's what propels the aircraft down the runway and into the sky, overcoming inertia and getting the plane up to speed. This force is generated by the plane's engines, whether they're powerful jet turbines or spinning propellers. Pilots control the amount of thrust to speed up, slow down, or maintain a steady pace. Finally, drag is the force that opposes the plane's motion through the air. Drag acts like an invisible hand, pushing back against the plane as it moves forward. It's like air resistance, the friction that happens when an object moves through the air. The faster a plane goes, the more drag it has to overcome. The smoother and more streamlined an object is, the less drag it will experience. That's why airplanes are designed with sleek shapes and smooth surfaces, to help them cut through the air more easily. To stay in the air, an airplane needs to balance these four forces perfectly. If any one force becomes too strong or too weak, the plane's flight path will change. The lift needs to be greater than the weight to keep the plane from falling, and if lift drops below weight, the plane will start to descend. And the thrust needs to be greater than the drag to keep the plane moving forward. Mastering this balancing act is what allows pilots to guide airplanes safely through the skies, from takeoff to landing. You might be wondering how pilots steer such massive machines through the air. It's not just about raw power or speed, there's a fascinating system of controls at work, allowing pilots to guide airplanes with precision and grace, even in challenging conditions. The answer lies in the clever design of airplane control surfaces, special movable parts on the wings and tail that help the pilot control the plane's movement. These surfaces are essential for changing direction, maintaining stability, and ensuring a smooth flight from takeoff to landing. Let's start with the ailerons, which play a key role in turning the aircraft. These are small hinged sections located on the back edge of the wings. They might look simple, but they're crucial for controlling the roll of the airplane. When the pilot wants to turn the plane, they use the control stick to move the ailerons. By tilting the stick left or right, the pilot can make the ailerons move in opposite directions. Moving one aileron up while simultaneously lowering the aileron on the opposite wing creates a difference in lift, causing the plane to bank or tilt. This rolling action is what allows the aircraft to change its direction smoothly. This banking motion is what allows the airplane to turn. Without ailerons, making controlled turns would be nearly impossible, especially at high speeds. Now, let's talk about flaps, another vital control surface that helps pilots manage speed and lift. These are larger panels located on the inner edge of the wings, closer to the plane's body. Flaps are designed to move downward and outward, changing the shape of the wing. Flaps are used during takeoff and landing to increase lift and help the plane fly at lower speeds. By extending the flaps, the pilot can make the wing more effective at generating lift, which is especially important when the plane is moving slowly. When deployed, flaps extend downward, increasing the surface area of the wing and changing its shape to generate more lift. This also increases drag, which helps slow the plane down for landing. This extra lift allows the plane to take off or land at slower speeds, which is crucial for safety. It gives pilots more control during these critical phases of flight, reducing the risk of accidents. The pilot also uses flaps to adjust the airplane's altitude and descent rate, making sure every landing is as smooth and safe as possible.